Good evening, everyone. Welcome to TechZeed's Tech Talk series, Season 3, Episode 2, organized by the Software Engineering Students Association of University of Kelaniya. We are so glad to have you here for another exciting session of TechZeeds. Today's topic is Introduction to Devops, the modern software workflow. DevOps is one of the most in-demand areas in tech today, combining development and operations to make software building faster and smoother. So let's get ready to explore how DevOps is changing the way we work in the software world. To begin our session, I am happy to hand things over to our guest speaker, Mr. Danika Kumarasiri, DevOps Engineer Intern at H2O AI. He will guide us through today's topic and share his experiences in the world of DevOps. So over to you, Mr. Danika.
Yeah, hope you all can see my screen. So, yeah, just first let me introduce myself. I'm Danika. So, I'm a final year undergraduate from the same degree program you all line. And currently, I'm working as an intern in H2O.ai. If you all don't know, you can just Google for H2O.ai and see where I'm working at. Yeah. So some of y'all may be thinking, what qualifications do I have since I'm just an intern and I don't have much experience on this. But yeah, I was just like y'all. So got into this company and I got to learn a lot in the industry. And I'm currently working with experts from several countries. So yeah, I think I have enough experience to give an introduction to DevOps for y'all. So yeah, introduction to DevOps: code, ship, and repeat. So what are we doing? What is DevOps? And what do you all need to do to get into DevOps? These are the topics that I'll be covering today within another hour or less. Let's see. So yeah, and one thing before I start, I'm not a lecturer. I'm not an outsider. So y'all are open to ask me questions, and I know, and I'm conducting this in English since I was asked to conduct this in English. But if y'all have anything you all need to clarify or you all need to confirm about, and if you all have any questions, just drop me a text. Just send a message in the chat or unmute yourselves and just ask. That's all. So I'm just a senior. I'm no lecturer. I'm no outsider. I was there as you all around 3 to 4 years ago. So yeah, I'm open to questions anytime. So yeah, so don't be shy. Don't be nervous. Just unmute yourselves or raise hand or just drop a message in the chat. Yes. So first, what makes software development painful? Y'all may have seen this, y'all may have noticed this, but if y'all never have, when we compare software development, software engineering to other careers, let's say other engineering fields, other financial or management fields, we get lots of benefits. Like we get dinouts, we get outings, we get lots of privileges that other sectors do not get. As an example, like which other careers do have gaming rooms in their office, gyms, swimming pools? Like no other careers have these kind of privileges for their own employees. So why do we get these privileges? What do the company get back after giving us these privileges? Let me start like this. So software development is not easy. It's very mentally draining job. It's very stressful. It's very hard job to carry on for years. So to exempt from us from that, we get those privileges. So why is it painful? Why do we call software development a painful job? So we call it painful because there are several groups, there are several software engineers, like there are, let's say, data science, or there are web developers, full stack developers, and there is DevOps, and there are like ML engineers, AI engineers, UI UX engineers. There are lots of field under the software engineering job. So why is it painful? The first thing and the foremost thing, these jobs which I have mentioned have no connections with each other. You all may think, okay, I'm going to do a front end job, and of course, when I'm building the front end, I have to contact the back end team. But no, that's not how it works in the industry. So there has been no communication, there has been no nothing. And when an issue rises, when an error occurs, the first and foremost reason all the developers say, it worked on my machine. So I don't know whether you all heard of this or not, since you all are first years. Most of the times, something may work on your local machine, something may work on your machine, but when it comes to production, or when it comes to another developer's device, that may not work like that. And your excuse is always going to be, it worked on my machine. And then from that moment onwards, you're allowed to start debugging, you're allowed to start how to continue, and you're allowed to think of a proper way to start everything after this. So yeah, that explains why software development is painful, because it's less development and more debugging. So yeah, so what am I going to cover in this 1 hour or so? I'm going to tell you what is DevOps, and what are the main features of DevOps, and the core practices, and why do we need DevOps? Why does a company or an organization need DevOps? And what are the main tools? And if you are interested in DevOps, which you may or may not, how to follow that path, and what is going to be the path you are allowed to follow in the next 2 to 3 years. And there will be a quick Q&A session, which I'll be answering your questions if you are interested. Yes, so let's dive in, I guess. Yes, so what is DevOps? DevOps stands for Development and Operations. As for the development side, as you all know, all the software developers, software engineers, full stack engineers, backend engineers, front end engineers, everyone comes to this software development side, and there's a separate side to manage the production. Let's say, if there are any issues, some of you may have seen, like several months ago, there has been a meme going around social media regarding a pick me notification which says test. And after that, a senior QA engineer or someone was there was a vacancy open for a senior QA engineer in the pick me campaign. So just like that, those are the ones who manage the operation side, the production side. So software development and IT operations are two sides which do not connect with each other. They are just like the software development team develops and the IT operations team take care of the production, but they don't have any sort of communication with each other. They don't blend in. They are two separate groups which are not working with each other, but takes care of the same problem. So this is where we come in, the development and operations engineers, DevOps engineers. We are the bridge between software development and IT operations. We are the medium which works as which work together with both teams to install a bridge to make them communicate with each other and make the life simple for them. So yeah, what do we do? What is our goal? Like, if you are to be a software engineer, sorry, if you are to be a DevOps engineer, what are you going to do in the industry? So, what do we do? Simply said, we do the automation. We make everything simple for the development team and operations teams. How do we do that? I'll explain that later. So, the three ways uh, we join in with the people, and we make the automation process, the process easier by automating it, and we make the flow way smoother. So yeah, that's what simply DevOps is. So what do we do? The core practices. Just let me know if I'm going talk too fast. So since we have only an hour, I'll be going all the basic things a little bit faster, and I'll explain your career and the things you all have to do in a the more understandable way. So I'll be going through these things a bit faster. So yeah, the world before DevOps, as I explained, the developers are a separate team. The operation teams is a separate team. They don't talk. They just, like, let's say there's a wall between both teams, and the development team throws their development code, their product, to the operations team or over the wall, and they push that to the prod, and it breaks. Why does that happen? Most of the time, before DevOps, there has been no communication with each other. There has been no connection with each other. So the developer team, the developer do their part. They test it out. They do their thing. They build it. They do what they're supposed to do, and they say, okay, it works on my machine. So their target is accomplished. They have done their part. They have a working thing which runs in their local machine, and they have no other way to test it out because they are working in their machine and it is working on their machine. They can't do anything that's working for them, so they just hand it over to the operation teams, and they push that to the production, and then somehow it breaks the production. No one knows how. IT operation teams doesn't know how, and they point out to the development team, and they say, okay, but it works on my machine. This is a very, very common thing when you go to the industry. This conversation is literally everywhere when you go to the industry. I have experienced this like several times even. So this is to be expected. So this is the pain when you are not involving the DevOps engineer. And also another key point, since the development team and operation teams are not in contact, it takes like weeks or sometimes months to ship a simple feature update. Like, you all may have seen some small time companies, startup companies, they have product, and y'all, I don't know whether y'all are into this or not, but there are some small time companies which have their open source softwares and everything, and people request fixes. The customers needs, like, they ask for new features and some fixes, but since these small time companies, startup companies, do not have development and operations engineers, DevOps engineers it takes weeks or sometimes months to add that change, to fix that bug, to ship another feature, to release a new version. So why does that happen? Because developers are taking so much time developing that, and they have to test that by their own. They have to do all the unit tests, integration tests. I think you all are software engineering undergraduate, so you all must have an idea what I'm talking about, how the testing is working. So uh, they test it, and they testing on their local machine, and then they hand over it to the operation teams, and that thing takes weeks or months. So it is very draining to test everything manually, and to hand off that, it takes a lot of time. And also, since everything is tested on the local machines, and since there has been no bridge which connects development and operation teams, it is very risky to push that to the production. And after we push that to the production, if there are bugs, or if it is not working as it should, it may cause a very big downtime, which can cause loss of customers, loss of customers trust, and when it comes to budget, the financial status may drain too. So, and also, to if we are facing any downtime, or if we are facing any bugs, we have to roll back to the previous version, and that is very time consuming as well. So that's why we are here. These are the pain points before DevOps came into the industry. So now, what do we do? What do we initiate? What do we do as DevOps engineers? So the first thing, and the foremost, and the main, and the most important thing, we establish the collaboration and the trust between development and operation teams. We are the bridge. We talk with each other. We do the talking. We explain everything. We test everything. We are the ones who hand over that. We hand over the finished development, the finished product to the operation teams. So we act as the bridge. So we initiate the communication. We initiate the collaboration. So it will be way smoother, and the communication is established. So we have to expect less issues here. And also, when it comes to automation, what do we do here? Let's say there has been a new feature requested by a customer, and the development team has implemented that. And from their side, they say, okay, this is done. We have implemented the requested feature, and it is running on my local machine. But still, they have to run some unit tests and integration tests. So what do? We come there. We have automated scripts. We have automated deployments. We have scripts, or let's say workflows, maybe pipelines. Some of you may have no idea what I'm talking about. You all may never know what a pipeline is, but it's good to understand. Just go Google it and search what a pipeline is. Pipelines are, simply put, automated actions. So let's say you all want to run a unit test every time a change has been pushed to the GitHub repository. So what we do is we write code to do that automatically whenever a user push a change to the repository. Excuse me. So that's what we do, automating everything. And also, in the next 2 to 3 slides, I'll explain what are our duties as well. So the development is done, and we run the automation tests. And after they are successfully completed, we are the ones who hand it over to the operation teams. And then when they approve that, we run some scripts, and we do not get involved. No human get involved. All the things are automated and pushed to the production. So this makes it less riskier, and more smooth. So that's where we come in. That's the uh, main responsibility we have. Yes. So a simple example. Let's take a bridge. There are two cities, and we have to build a bridge which connect these two cities. So the development team, in this example, the architect, they design the bridge. They have the blueprint. They're the one who designs it. They're the ones who draw it, and then they hand it. The blueprint is handed over to the builders by the architects in the industry to the operation teams. But when they go through the blueprint, they find out that the materials which are used in the blueprint are not available for them, and they don't have access to these materials. So there's a problem that architect doesn't know what are the resources that builders have, and the builders doesn't know what are the uh, materials that architect expects. So this is the issue. So they can't move on. The architect says, "Okay, I handed over the blueprint, and it's your job to make the bridge." And the builders say, "Okay, but we don't have these materials. I don't know what you all are expecting, and this is stuck at here." But a proper DevOps approach makes it. Uh, we integrate a team. Like we act as a engineering firm, civil engineering firm, let's say. So we have architects, we have builders, and we have the bridge, which are the DevOps team, which connects each and everyone. So their architecture knows what are the materials they do have and what are the things they don't have access to, and the builders know what do they have to know and what the architecture meant by, and the blueprint is handed over to the builders, and the bridge constructs smoothly. So that's what DevOps team does. We act as a bridge which connects these two teams. Yes. So what do we do? What did I mean by collaboration? So as I have explained like 2 to 3 times before, we initiate the open communication, and we share metrics and mutual respect for skill sets. So let's say there are front-end developers, there are QA engineers, data analysts, uh, BA engineers. So what do? We initiate contact with each other, and we participate on all their meetings, calls, to understand what are the issues they are facing. So we have an idea, and all the team members have idea, and we know how to solve everything, and we help to automate everything. And when there is trust, uh, everything gets smooth. And since we are automating everything, we are providing the solutions, we know that we are to expect less risks. So less risk means more faster releases and less fearful releases. So faster and less fearful releases mean the success of the organization or a company, software development firm. So that's why we are here to initiate collaboration from one team to another team. This is not regarding only development and operation teams. We work with everyone. Let's say QA engineers, UI UX engineers, AI ML engineers. We work with everyone. We are the one who collaborate with everyone and make everything going. So some of you may have no, but some of me don't. But as of now, as of 2025, there has been a very big improvement in the job industry for development and operation DevOps engineers, because we are the bridge and we automate everything, and as of now, the software development is running on automation, and AI and automation have been a big part of software industry as of now. So therefore, we have been doing a very big job here. So there has been lot more vacancies, lot more uh, opportunities for development and operations engineers. So yeah, okay. So the first thing, CI, continuous integration, which means always ready to merge. Let's say, so get think of yourselves as a software developer, okay, a front end developer. You'll have changed, let's say, a background color from one color to another, and you push these changes. And whenever, okay, the example I'm saying, this may be a simple change. You all may think, okay, why do we have to run tests on this? This is a simple CSS change or whatever it is. I don't have any idea on front end, so excuse me. So this is a small change. Why do we have to think about this? But let's say in the industry, these are not the changes that's going to happen. There may be bigger changes. There are like, we need production breaking changes. So whenever these changes are made, all the changes are pushed to the GitHub repository, a separate branch. So after we push these changes to the specific branch, there needs to be some tests to identify whether these are breaking anything which has been already deployed, or whether these satisfy the requirements, and whether these things do what they are expected to do. So, sorry if you all heard the sound. Um, so yeah, these tests are need to be, like, they're supposed to be ran by software developers itself, but we come there, we automate these tests, we we write scripts, and we what we do is, whenever a developer push something to the a specific branch, all these tests must be run, and the result must be shown, so the developers can understand, okay, this test is passing, but this specific test is failing, so I have to take care of this. This may break the production. So we are just running the automation scripts, we are just writing the automation scripts, and whenever the developers push their changes, they can have a proper idea on what are the breaking changes, what do we have to change, and all. So uh, after that, if every test pass, which is a very big thing, because developers doesn't have to worry about these tests anymore, because all of these are automated. Since everything is passed, there comes a human, let's say a project manager or a tech lead or a solution architect. I hope you all know these positions since you all are software engineering undergraduates. A human, has to approve these changes, and after that, it can be merged automatically and it can be pushed to the production. So what does this do? Since these automated tests, for an example, unit test, that can be integration tests, whatever it is, it triggers these tests, and the results are shown to the developer, and this makes fixing bugs much easier. And also, since we are not pushing this straight to the production, the cost is way cheaper, and it is way easier to manage since all are taken care at the development stage. So yeah, what do we do? Like, what are the continuous integration tools that we use in industry? uh, I hope you all have GitHub account, you all have used GitHub before. So if you all have GitHub account, create a new repository, and there will be a tab saying actions. So in these action tabs, you'll be able to see the actions which are supposed to be developed by the DevOps engineers. So y'all may not uh, see any GitHub actions whenever y'all create a repository, but if we have time, I'll show what are the what these things look like, and how these CI pipelines work. So in GitHub, there's a separate part called GitHub Actions where we can run workflows. And also, we use something called Jenkins, which is specifically to run these jobs, which are called pipelines. And Jenkins and GitLab CI is specifically designed for continuous integration. So, yeah, and CD, continuous deployment. What do we do? So, whenever as I have mentioned before, whenever a developer push changes to this branch, and after a senior, let's say a developer or a solution architect or a tech lead approves these changes, they are being merged. And since these are approved, this code is always ready to be deployed or pushed to the production. That makes a total difference when it compares to normal standard deployment where DevOps engineers are not mentioned. I mean, the previous situation which I have mentioned where developers and operation teams are separate. I have told that I have mentioned that okay, how can I explain this? So yeah, I have mentioned that it takes a lot of time for these teams to implement a new feature. But since we have implemented continuous delivery, every time a developer pushes some changes and someone approves these changes, they are ready to be pushed into the production, which sometimes when it comes to a bigger company, let's say Netflix, let's say Alibaba, let's say Amazon, or huge companies like multi-billion dollar companies, they push changes to the production like 100 times per day. Like some minor bugs, some minor features. This is done because development and operations, DevOps engineers are there. So basically, we help the developers to push changes. And since we are continuously pushing changes to the production, there is less risk because we are not pushing any major changes in a pack, in a whole pack. So there is less risk, more smoother actions. So that's why we are here as DevOps engineers. That's what we do. We make everything smoother and less riskier and makes it easier for everyone in the software development. Okay. So the continuous pipeline. What do we do? So as software engineers, as you all know, the developer's job is to plan the product according to the customer's requirements and implement that plan. The code, the development part, that's the developer's job. But previously, DevOps came into the society. Building that and testing that was development engineers, developers' jobs as well. And also, after that, they hand over it to the operations team, and the release, deployment, and operating and monitoring part was operation team's job. So, DevOps came into the society, into the industry, and what we have done, we have initiated automations, we have made scripts, and we have built pipelines to build everything, and test everything. And also, as for continuous delivery, everything is ready to release, and also everything can be continuously deployed. So now, as of now in the industry, planning and code is the only thing developers are responsible of, and operating and monitoring is the operation team's task. And building, testing, releasing, and deployment is automated, and the automation is done by the DevOps team. That's where we come in. So we do a very important job in the industry. We have a big responsibility. So this is what we do. As I mentioned earlier, automation stands for this build, test, release, and deployment task. We automate everything. That's what we do. So, why DevOps? Why do the industry need DevOps? Why do some organizations need DevOps? So, um, the main concept, as I mentioned before, frequent releases, smaller releases, and we make the risk way lesser. And also, the daily releases or let's say weekly releases make customers' lives way more easier, because let's say you all have a product and the customer has requested a release. Okay, a change. Let's say they wanted a dark mode for this. Like you all only have a light mode, so the customers are asking for a dark mode. So what do we do as developers? Someone implement this dark mode, and then as part by part you all push these changes, because these are not done by a single person. There are several people in a single team. So the changes are being pushed and all the tests are automatically run, and then after everything is done, we can check whether there are any tests which are failing, and we can make the changes, and then we can push everything to the prod. And since these are very small and daily releases, this risk is manageable. And also another thing I have to mention, since we are the ones who managing the deployment, we are implementing features to, if there are like a major breakdown in the production, and we write the scripts to scan whether there are any issues in the production, and if there is, we run the automation scripts which are meant to roll back to the previous version. So there is no downtime for the production. Everything gets way smoother and less risk, and no financial risk, and no risk to the customers at all. So this is how it is done. And delivering values faster is one of the major plus points when a DevOps engineer is involved. So better teams. As I mentioned before, the communication was not there at all when it comes to the uh, when, before the DevOps was invented. So everyone was pointing fingers at everyone. There has been no communication, no collaboration, no nothing. So since we are here, we are contacting everyone, we are working with everyone, we know how everything works, and we are making them their life easier. So higher job satisfaction, increased efficiency, and all the team members can help to uh, make their goals, or you call it, fulfill their goals. So yeah, we are sharing tools, we are sharing metrics, everyone has idea on what they are working on. So better teams make better solutions, better efficiency, and better everything. So yeah, and releases that don't break teams. So mean time to recover. What does that mean? So, let's say you all have experienced some issue in the production. So how much time does it take as an average to recover? To, let's say, it may be roll back to the previous version or to fix the bug, whatever it is, but to make everything normal, how much time as an average does it take? That's the mean time to recover. And mean time between failures. Let's say you'll have pushed a change onto the production last Monday, and y'all are planning to push a change to the production next Monday, and both of these are going to fail. If this breaks, that's the time between failures. So mean time between failures, this time should be more important because we are to make this mean time between failures as long as possible, because we can't experience, the customers can't experience a mean time of failure, like the time the customers can't experience failures again and again and again. If they do, they'll lose the trust on the customers, so they won't be able to do anything. They lost, and they lost the trust in the production, so they'll, like, we'll lose the customers. So that's a risk we have to take. So we are to make mean time between failures as long as possible and mean time to recover as less as possible. So how do DevOps engineers comes into this? So since the changes are small and all the things are tested automatically, there will be a way lesser chance to break anything, and the mean time between failures are going to be much bigger, and mean time to recover, since we can roll back to the previous version, or we can push the fix to the bug way easier, since there is automation, the mean time to recover will be way lesser. So yeah, automation. Let's say since you all are working on something, uh, you all need something to be automated. Like you all want to test something, or you all want to test something on a live server, or whatever it is. Like you want to test an API call, whatever it is. So this task is very boring. I know, as for developers, you all hate to test everything one by one, but that's something you all need to do as a developer. But what do? We let the robots. By robots, I mean the pipelines, the scripts. We make them, and we make them do that job for you all. So there you go. You all don't have to do that boring work. You all can work on the development, and you all can fix the bugs, and all the testing and everything is automated. And also, infrastructure as code. Infrastructure means, let's say, you all want to test something, not only on your own machine, but you all need a Linux machine, a Windows machine, and something which has Mac OS, or an iPad which has iPad OS, whatever it is. Something. If these are your requirements, we are the ones who provide you guys with the infrastructure. We just there are these thing called virtual machines which are in the cloud, and we are working in the cloud. So we are providing you all with the infrastructure, and developers can focus on testing and working in these, and they are not supposed to integrate with the infrastructure. We are the one who will be providing infrastructure, and we do that by managing the code. Infrastructure as a code is simply explained there. So the landscape and your future. So if y'all are planning to follow a DevOps path, I think we have like 15 to 20 minutes more. So I'll go through this and I'll explain this, since we have some time left. What do you have to follow? what are the basic things you all have to follow if you all are following DevOps path. Main thing, uh, as I mentioned before, pipelines or GitHub Actions or everything, these run on cloud. I hope you all know what cloud is. So if you all have used Google Drive, let's say Netflix or Spotify, these are hosted in the cloud. So cloud is like something this the rather than physical servers which have like you all have seen in movies, like the servers which has like lots of lights and like the box kind of things, supercomputers kind of things. But these cloud service providers have their own thing, and we which we can use by paying them in the cloud. So we can pay them and ask them, we need this kind of machine, we need let's say 8 GB RAM, this kind of VGA, and this kind of storage, and you can, and it should run this OS, and you'll get that from the cloud, and you will work on that, and you'll be able to work there. So that's basically, I mean, this is like 0.01% of what cloud is explained. So yeah, as for the cloud providers, as a DevOps engineer, a DevOps engineer must know what everything about a single cloud service provider. That can be AWS, which is Amazon's cloud service provider, Azure, which is Microsoft's cloud service provider, or GCP, which is Google's cloud service provider. And also there are Oracle Cloud, which is provided by Oracle, and Ali Cloud, which is provided by Alibaba. So, but Ali Cloud and Oracle is not used a lot, but some companies use. But I highly recommend you all to go for AWS or Azure, since GCP is not used in Sri Lanka a lot, but GCP is being used, and it's way easier, and the easiest cloud service provider to use is AWS, and you all have a free tier. You all can create accounts. You all will be asked to input a credit or debit card, but there's a free tier. There's nothing. You don't have to pay anything to create account or use the resources. You all can use the resources freely, and there is a limit of the free for the free tier. So yeah, you all can. I suggest AWS, since I learned AWS and I started with AWS, and now I'm working with AWS, Azure, and GCP, everything. But it's easier to start with AWS and make your way through DevOps. And version control, Git. Don't miss things. GitHub and Git is two things. Git is the version control system. Like, it is the tool that is maintain the code, and GitHub is a service provided by Git. GitHub is a company, it's a provider. So Git is something, GitHub is something which use Git as their technology. So you all have to, whether you all are DevOps engineers, cloud engineers, whatever it is, DevOps engineers, whatever it is, you all need to learn Git commands. You all have to learn how to work with GitHub in your terminal or command prompt. What are the Git commands? That's mandatory for all the software developers. And infrastructure as code. So what is it? Let's say we have our company has a 20 software developers in our team, and each of these developers need Linux machines, or let's say Ubuntu machines. So it's very time consuming and effort consuming if we provide each with, like, we start up a machine and provide them with the credentials, and we start another and provide this. Like, we have to go through this 20 times to suffice the developers' needs. So that's where Terraform or CloudFormation comes in. So we we write the code and we ask them, these are the requirements we have, like it has a billion arcs, this is the RAM we need, this is the storage we need, and we run the code. And when we have to specify our requirement, and Terraform will automatically run this script and provide users with the required machines. All that can be machines, that can be storage, that can be whatever you want in the cloud. This can be done through Terraform and CloudFormation. CloudFormation is specifically for AWS, and Terraform works with all the cloud service providers. Terraform is a specific technology which use HCL as their language. CloudFormation is something which is introduced by AWS itself. So yeah, containerization and orchestration. So let's say I don't know whether y'all have developed anything yet or not, but if y'all have, it is running on your local host in your local machine. How do y'all expose that to the public? If one of your friends, or let's say someone from another department wants to access that, or y'all have made a portfolio for yourselves, and an interviewer needs to access that, how y'all show that if y'all don't have your laptop? So that's where Docker comes in. Docker is like it's like a container. Let's imagine a container, and what you do is you pack everything and put inside that container, and you ship the container. You send the container to the one who wants to access that. So that's where Docker comes in. And Kubernetes is an advanced version of Docker, which has more features. And Docker does the containerization, which I have mentioned, the put everything in the container and sending the container. And Kubernetes do the orchestration, which means they provide what's inside the container in a proper way. So that's what containerization and orchestration stands for. And for the entry level job for an intern, you all don't need Kubernetes. Kubernetes is a paid industry level service, so you all don't need to know the core principles of that. You all just need to know what Kubernetes is and how it is used. So that's that. And CI/CD, which I have explained before, which you use in GitHub Actions, Jenkins. Okay, so the real world impact. AWS, the most used cloud service provider, and as you can see, deploy code every 11.6 seconds using a pipeline. So imagine how Devops has implemented change to the society. So every 11.6 seconds, that's a lot. So that can be any app you all are using. As for Sri Lankan examples, Pick Me, and I think Pizza Hut app. Uber, of course, uses these kind of automations. Like, since they are big companies, they use these kind of things. So these are examples. And when I go to global, Netflix is a very CI/CD heavily used thing, because it uses many things, lots of AWS services, and also it uses GCP as well. And also you all have to note that a product does not simply depend on one cloud service provider. So it may be AWS, GCP, or both. So that's how it works. And also GCP. So getting hands-on. How do you learn? First of all, learn Git. Make a GitHub account, make a repository, and work with that. Push changes, write pipelines. And if you all ever need, like if you all think that you all are going to follow a DevOps path, I think I'll just drop my LinkedIn account or my WhatsApp number, so you all can contact me, and I'll let you know what are the things you all have to follow on, what are the things you need to understand before following the DevOps path, so it will be easier. So first step, the most recommended thing for not only for DevOps engineers, for everyone, learn G. That's a must in the industry as of now. So containerization and infrastructure as code, this comes later. But if you are getting hands-on experience on DevOps, if you all are trying to follow a DevOps path, these are the must-have as a DevOps engineer. Yes. So that's kind of it. Um, these are the things I explained. DevOps is a cultural shift focused on collaboration. We implement the bridge between every team and the core technical drivers, continuous integration and continuous deployment, testing and deployment all work together. We are the one who's responsible of that, and learning tools. So these are the main things I have to discuss. But if you all need to know way further, or if you all are going to dive deeper into DevOps or cloud, just let me know. And if you all have any questions, you all can ask. And can someone say, do we have some time so I can show how automation pipelines work as well? So I can share my screen and show you all something. Will it work for y'all? Hello. We have time, like it'll take like 5 to 10 minutes as well. No, like, yeah, 5 minutes or so.
Yes, yes.
Okay, nice. Okay, let me. Okay. Yeah, I think you all can see my screen, right? So can someone confirm whether you all can see my screen? Yes, sir. Okay, nice. So these are what we do. This is a change I have pushed myself into the our repository. So as you all can see, uh, these are the tests which have run, and as you all can see, um, one failing, one skipped, 4 successful checks. I'll show. So this is how it works. Under any repository, there's an action page, action tag. So there you all can see these are the pipelines, these are the scripts that have been run, and these are the passing tests, and these are the failing ones. As you all can see, these are the workflow files. Uh, this is a file, YAML files that run these texts. So yeah, for a developer, these are supposed to be run manually, but since we are here, we have implemented these changes so that so everything is coded and nothing is run manually. So after, as you all can see, it says waiting on code owner review from these are my supervisors. So once they approve these changes, I can squash and merge, and it runs a Terraform apply command. Once this has been approved, and all the change are merged with the main branch and pushed to the production. So this is how it works. This is like this is a simple implementation of the pipeline. There are lots of things, like this is a very simple one, and some pipelines are like 1,000 lines long, and some what do you call it? Machine learning and AI pipelines are like where they train models are like very long and they take lots of time. So that's how it is done. Um, so yeah, that will wrap up this session. I'll hand over to back to you all guys.
Oh, okay. So that was such an insightful session. A big thank you to Mr. Danika Kumar Siri for sharing his valuable knowledge and experience with us today. And thank you everyone who joined us this evening. Your support and enthusiasm make Tech Seeds possible. So that's all for TechSeeds Season 3, Episode 2. Stay tuned for more exciting episodes coming soon. So I'm Sani Mohotige signing off from TechSeeds Introduction to DevOps, the modern software workflow. So thank you everyone. Good night.